All right, guys, this is building a substreams from 0 to 100. So, first of all, I'm going to be going through a challenge that my friend and Ben, made. And this just has you build a substreams. So, this is a challenge. So, if you want to actually practice building substreams, please go do the challenge first and then maybe watch the video later. This video is kind of like the answer key. So if you did actually want to get practice doing this, um, please go do the challenge. Um, this video is like if you're really stuck or something, or maybe you're just curious about substreams and you want to see what they can do. So let's get the show on the road. So first, I'll put a link to this in the description. You just want to clone this and then you can start the challenge. So clone that. And this is a this entire repo is the same command. When you run substreams init, you will get um, a different version of this challenge. This challenge was made using substreams init, and we just changed a few things so that you guys can go figure things out on your own with a little bit of guidance. So while this is downloading, let's go into some of the prerequisites. So first, you'll need to know Rust. I'm not super good at Rust, but I can write substreams. So you need to at least know things chapter 1 through 9 in the Rust book. And as you're doing the Rust book, make sure to complete the Rustlings exercises so that you're actually practicing and not just, reading stuff. Um, I'm not super good at Rust, and it's made building substreams a lot more difficult for me, so highly recommend. Also, there's a video that my friend gave a talk about substreams, so that's also a really good resource. And there's the Stripping Fast Discord channel, which can help you out, and we also made our own Telegram channel if you guys need further help. So the overall challenge is you'll be creating a substreams to filter through blockchain data and get the transfer volumes of certain NFT collections. And we're going to put all that data into a subgraph. So things you'll need, this is built with scaffold ETH. So we'll get into that later. And for the actual substreams building part, you'll need to, of course, download Rust if you haven't already. Substreams pass protobufs around to each other, so you'll need to install protobufs. And you will also need to get a authentication and API key. So you'll click on this, it'll take you to this graph website. You basically log in and you'll get your key right here, and then you can start using that. So I'll show you where to put that. Okay, so here's, checkpoint 0. It's the environment. So once our thing's done downloading, which it looks like it has, we will move into this challenge and we will go yarn install. And this will grab things we need for scaffold ETH. And then we'll start up a local hard hat chain. These three commands right here have nothing to do with substreams. This is just so scaffold ETH will work. It's to display a front end. Then we'll get into the meat here. So we'll open up our code editor and make it big, as well as zoom in, and then we'll get right into things. First, we'll run yarn chain, and this will start up a local hard hat chain. And then we will deploy this template smart contract we're not using, and we will yarn start, which will make our front end go. And the whole point of this is when you're done, you'll be able to see your data that you got on your front end. So let's go to localhost. So once you get all the scaffold ETH stuff started, this is where the substreams actually begins. So it begins with providing an ABI. So you need to provide an ABI for your smart contract and run a command which will basically generate a bunch of Rust types um, according to the events that exist within this smart contract. And there's other things that it generates too, but for our purposes, I think we're just using the events. So here's the whole challenge. You'll spend most of your time here in the Substreams challenge, and let's start by going to ABI. Okay, so our ABI is empty. When you use Substreams init to build your own substreams, it'll ask you for an ABI and you can provide it in the command line. This is just to show you that, if you have another contract that you want to use, events from other contracts, you can put in any ABI. So we just copied that. This is the ABI for Board 8 Yacht Club, which is the default one, but this is just to have you practice, putting in your own ABI should you want to build your own substreams. And so, yeah, it just tells you a little bit more about it. Next thing to look at is the make file. You don't actually have to be in the make file in order to run this command, but this is just to show you some of the few commands that exists. But without getting into too much detail yet, let's just continue here. So to use the make file, we need to move into the correct directory, and then we can go make build. And this is going to build all of the Rust types, and we'll see where this comes into play later. So we run make build. All right, now we can start building. So the first thing we'll need to do is define our protobufs. Cool, so that just finished. So the way substreams work is there's map modules which basically work as there's like coin filtering machines where you put coins in and then it filters things out. So that's a filter. The map filters things, and the store module lets you aggregate things. And so by using them together, you can filter, and aggregate, and get the data you want. So we need to define what these different modules, what the map and store modules are going to be passing to each other. So that's where we're going to make our protobufs. So you'll need to go to proto, and in contract.proto, this is empty because we cleared it, but if you use substreams init, there should already be protobufs generated for those events. If you're building your own, you'll need to define your own protobufs. So we're going to get transfers. So we're going to paste this into here. And basically, protobufs can't have like multiple things in them. So we need to make a protobuf that's just transfer singular, which is going to have an address, name, and symbol. And then we're going to have a transfers protobuf that just has a field of transfers. So let's save that. And we need to run a make command now. So here, just explains some more stuff. I'm just speed running through this. You guys should definitely have a read at this. It'll explain it a lot better than I can right now. We'll run make protogen, and this will generate protobufs for us. So we define them here, and now we can actually start using them. So it looks like that finished all well. And now we're going to go define the structure of our first module. So a lot of Substreams development is it's very circular. You're going to be doing the same steps over and over again, depending on how many modules you have. So let's go to the substreams.yaml, and this stuff just leave as is. You'll have to comment out these modules, and you'll be making them yourself when you build your own. So our first module is called map apes, and there's two kinds of modules. As I said, there's maps and stores. So this first one's a map. The initial block is when it starts reading blocks. the input is it's literally going to take in blocks, and we're just going to filter that data. And the output is, a protobuf of transfers, right? That looks familiar. Here's our transfers right there. So that's where it's going to output. So here's the YAML. So we gave it the name, we gave it the map. It's of type map, and it explains some more stuff. And now we can go to our librs. So this is where we'll be spending most of your time, is actually writing Rust in the librs. So if you go to source, librs should be right here, and you are greeted with this. So here we filled out some important things, um, but the hard things are not filled out. So that's what I'm going to be going through today in this video. So let's see what is filled out. So our module is called map apes, and it takes in a block. It returns the transfers protobuf, which we defined, or an error. There's a helper struct. Ben and I built this, so you guys can go copy and paste that if you want to use this in your own projects. And this just makes an RPC call to get name and symbol. And we instantiated the transfers protobuf, and we are collecting all that stuff. So here's the goal of the module. From a big scope, we want to search the block, right? Each block that this map module is taking in, we want to filter out, and we want to get a certain event, and we want to populate our transfer protobufs with our desired, um, with our desired transfers. So first thing is you'll also be spending a lot of time in this library. There's a few libraries that you need to use for building substreams. This is the first one. It's called Substreams Ethereum. And here it shows you what kind of methods you can use on the block. So our substreams here takes in a block. And what we need to do is we need to find an event address. So let's just delete this and let's begin. So we want to make a vector called transfers, and we're gonna basically iterate over the block, and we're gonna use a method that you need to find. So in the challenge, you'll need to find this method here. I'll tell you what it is. You need to use logs. So you can look over transactions, receipts, logs, calls, events, and I think these are all iterators. And so when you use .logs, you basically get this thing called log view. And on log view, you have more methods, but we'll use log view, and then we'll get into what we need to do after that. So we'll go block.logs, and as you can see, it returns an iterator. And over these logs, we need to filter map these logs, because we're going to filter them, and then we're going to map them over our transfers protobuf. So we need to use the pipe operator here, and here's our log, and there we go. We'll open that up, and we're looking for a specific event, and this event is called a transfer event right here. So, you might be like, okay, where is this coming from? Well, we're looking for transfers, and these NFTs have a transfer event. And this transfer event is actually coming from our ABI. And when we did build make build, it built all these Rust types. So transfer event is now a Rust type, which we can use to filter things. So there's a method. Um, there's a method called map, or match log. It's written somewhere in the challenge. Um, there's a few different ways you can do this. I'm going to use match log here, and what we're looking at is the log, which is log view, but it's log.log because we're uh, looking at what the actual log is of the log view. Um, so here, uh, what we've done is we've successfully iterated over the block, right? So the first step is to find all events that match the transfer event. So here we're trying to match it, and if it does, step number 2 is to pass the address that emitted the event into token meta so that we can make the RPC calls we need to get that information. So here we provided token meta for you. So we'll bring that up here. And here we want to give it uh, the address of the log. So we'll go log.log. So now we're looking at um, the actual event itself, and then we'll get that address. So now our token meta has uh, name and symbol. So now that the token meta struct has this, we can go token meta and we can filter what the names are. So let's see. Now we're on number 3. So add a check that the name field on token meta contains ape. So we only want to grab events that have ape or transfers. So we'll go token meta.name contains ape, capital A and PE. So here we're saying if token meta does contain ape, then we're going to populate our protobuf, right? So this is this step right here, filter by name. And now we're ready to um, populate our protobuf. So I'm not a big expert at Rust. We do need to return some here because the token meta dot name might not have ape. I think that's why we're returning some here. Hex encode is a function that just formats uh, addresses nicely. But here we, as the to do for here says, we want to give it the event address. So we already know how to do that. That's log.log.address. And token meta.name, token meta.symbol, that's already done for us. So here we are good. Now we want to remove this semicolon right here. That should probably be removed from the challenge. And now we want to, because we're getting some, in the event that there's none, we want to return none. And if that's not the case, that the log matches the transfer event, then we also want to return none. There we go. All right. So we're almost done with this map module. All right, then we'll assign the transfers field on transfer protobufs, the vector. So because we have a vector here, we need to dot collect. That'll collect all of those nice things. And here we need to put our semicolon, and we're going to, this part of the challenge needs to be edited. This is actually already done. This is the answer right here. It's just okay, transfers, transfers. So now we have our, we iterated over the block using logs. This is a very important part. So in the library, depending on what you're looking for, you can look for different things. In this case, we're looking over logs. So just, this is the important stuff. Then we're filter mapping over the logs, and we're basically filtering. We're making sure that the log is a transfer event. and then we are getting the name and symbol of that token, and we're just making sure that the uh, token name contains ape, and then we're populating our protobuf. Uh, Here's, if we don't find anything, we're just, none, and then we're collecting it, and we are, uh, this returns transfers, right? So this is what it's going to be returning. It's going to be returning transfers. All right, so let's save this. Also, these are red. Don't worry about those. The challenge still works even though those are red. All right, so now we can go ahead and go test our module. So we need to make sure that we did this correctly. So if you go back to your make file, there is a stop block. So this is how many blocks the whole module is going to run over. And this is the starting block, obviously, and we need to specify the module. So we're going to be using make run, and this will just run our module. So our module is called map apes. So we'll put that there, we'll save it, and let's see what the next step is. So here it tells you what some of the make commands do. What we want to do is we want to make run and make sure that block 15,000,002 looks like this. This is where you'll need your API key. So this is that token we were talking about earlier. If you put it in a uh, little bash function, it'll make your life a lot easier. So I have one of these, and you could run SF token and automatically get your key. So my function is just called SK for Substreams key. Cool. So I have my token now, and now we'll go make run and see what that outputs. Maybe I did it wrong. Maybe I didn't. We're about to find out. Okay, cool. So here's block 5,000,001. Here's block 5,000,000. So we definitely see transfers on here. So here's block 5,000,002. So we have base C, ape reunion. And let's go check the answer key. It's supposed to look like base C, ape reunion. Cool. So we're doing the map module correctly. Also, one thing to note, don't run too many blocks because your API key does have a certain limit, so you don't want to run out. If you don't know what's going on and you need to debug, you can use this, and this will debug out in the terminal. Okay, so now we've successfully filtered from the block all transfers that have the name ape in them. Now we want to aggregate these because we want to count. We want to count how many times a NFT with the name ape has been transferred. So remember that in map modules, we can't aggregate anything. It's just a filter. So we're going to make another module now that's basically just going to aggregate how many times each token has been transferred. And this is a store module. So once again, we'll go back to the Substreams YAML because we're going to make a new module. So we need to make a new, we need to define what the new module looks like. So the name of the module is, it should tell us it'll be store transfer volume. Store transfer volume. And this is a store, right? We have maps and stores. And this part is a little nuanced. So map modules have an update policy, which means like what is it actually updating? So let's open this in a new tab. So there's a few different update policies. You can read these docs here, but what might be more helpful is actually looking at the library. So here's a note. There's a difference between Substreams Ethereum, which is where we got .logs from, and Substreams or just a Substreams library. So this is for map modules. So if you store, or I meant to say store modules. So these are for store modules. So you got these, and you'll click on store, and this will tell you all the different kinds of store modules that exist. So you have deltas. I'm not really sure how those work. These don't. We're not doing those in this challenge, but you'll notice a pattern. So they all say store, and then there's either add or get or max. So this is the update policy, and the value type is this second part here. So float 64, int 64, raw. So we have a bunch of transfers and we want to aggregate these transfers. So we want to use add because we're doing addition. So we'll go store add something. So it'll be one of these, and you can mess around with these and guess. Um, as you're doing the challenge, I think the challenge actually tells you what we need is store add int 64, right? Because we're basically just adding the number 1 to a running total of how many times a token's been transferred. So for our update policy, we'll go add, and for a value type, it's int 64. And our inputs, um, this store needs the protobufs that we just generated from our map module. So we're going to take in our map module as an input. So our inputs will be a map and specifically map apes. Okay, so we've successfully updated our Substreams YAML, and now we're going to go back into our librs and actually start working on the store module. So our store module needs a second argument. So right now it's taking in the transfers from our map module, and we also need the actual store itself. So if we scroll up here, we already have store add and store int, or store add int 64, and that's what we're going to be passing in as our second argument. So we'll just call it store, and specifically this will be store add int 64. All right, so that's to do number 1 is done. We've given our store module, and now we want to iterate over the transfers so that these transfers that were coming in, there's a bunch of transfers, and we want to iterate over them and start using our store to aggregate the values. So you can read more about stores on the docs, but they're basically key value pairs. So we're going to use a for loop for transfers in transfers. This is the protobuf. And so we need to go transfers again to actually look at an individual transfer. And inside of that loop, we are going to use our store that we brought in here. And on this store, you can look at what kind of methods exist. So you have add many, delete, new. So we're going to be using add, right? Because we just want to do some addition here. So we're going to go store.add, and add takes in the first argument is an ordinal, and then you have your key and your value. So we're not using ordinals for this challenge. Honestly, I don't really know how they work, but you can just put 0 there. And for the key, we need something unique. So if we look at our transfers, uh, singular transfer.address, that's unique. So we need to use that. And every time we encounter the same address, what number do we want to add? We want to add 1. We want to add 1 to the running total. So here we're going to have 1, right? So here we've iterated over the transfers. We're good. We used the .add method. It even tells you there that wasn't a secret. And now our store module aggregates things properly. Now, we can't test our store module like we did with our map module because store modules don't have outputs. They just store and they aggregate. And so when we build our graph out here, we'll see what kind of other methods we'll use to actually get the value out of the store. So let's check back up with the challenge to make sure we're moving properly. Here's the update policy, building the store module. We tell you what's filled out again. We tell you the general goal of the module and, things you need to do explicitly. Um, cool. Next module, graph out. So once again, we're making another module. So we need to go back to our YAML and fill out this last module here. So the name is graph out. So we're going to be outputting this data into a subgraph. And the graph out or DB out, you can also output this data into any database in general. All of these, the final modules, they're all map modules, whether it's graph out or DB out. The inputs here, we're going to have, this is all explained in the challenge. We're going to, uh, by process of elimination here, there's not like a lot of things we can do, so it should be pretty obvious. But the store module it's taking in is store transfer volume. So this is so that we can read, like the actual aggregated count, and we need our map module so we have something to iterate over. So our map here is going to be map apes, and the output it's going to output entity changes into the subgraph. Okay, so after you're done with the YAML, you need to make your schema.graphql. So if you've built subgraphs before, this is nothing new. We have our schema. Nope, that's not the right file. Here we go. So we've given you the schema, right? Because this doesn't really have much to do with building substreams. This is just subgraph stuff. So here's the schema. Just plop that boy in there. And now we can go back to our librs and continue building our graph out. So once again, we tell you what's filled out. It returns entity changes. The container has been initialized for you. So right here, we have the container, right? Tables. And the OK variant is returning entity changes. So now we need to fill it out. So here, there's one more library to keep track of, and it's the entity change. So we're using tables um, right here, entity changes, tables new. So all the methods that you need to use will be on tables. So we have rows, tables, and rows. So once the container's been initialized, well, we need to add some imports, right? So we need to get we need to get the data out of the store module. So if you go back to the store library, where all the stores were, um, we have all of these, and we also have store get methods. So, because stores don't return anything, we need to go get it. And so store get int64, that makes sense, right? Because we have an int64 and we need to get it. So we need to use this module, right? And if you have a store, add like number or string or something else, you'll need to get the appropriate store get method. So here it says scroll to the top of the file. So a lot of these imports have been done for you, but when you're building your own substreams, you need to go get these yourself. So this is why we're having you guys practice actually importing these things. So from the store, we need store get int64, and we also need to import a trait on store get, which is get at, because we're getting a certain value at this specific key. So I believe that's a trait. So this is going to be store get. So we'll save that. And so now we have those appropriate imports. Pass in the store as the first function argument. So when you're building these modules, the order in which you give your arguments need to be the same way that they are in the Substreams YAML. So here we need to put in our store first. So our store is what uh, store add no store get, right? We're using the get method. We need to have store get int64 in here, and we need our map module, which is the transfers, right? So transfers is the transfers protobuf. Pass in the stores, the first function argument, that's done. Pass in the second function argument. Okay, so now we need to iterate over the transfers. So here we're going to be doing the same thing as in the store module for transfers dot, or no, sorry, for transfers in transfers dot transfers. We are going to be doing the following in a loop. So all of this is happening within a loop. We're going to use the tables container, which we just initiated. And this is where you'll need to check the library, right? You have these rows. Sorry, we're on the table struct. And on this, we can use the following properties. So we'll want to create a row for the table. And at this point, you might be like, okay, what is the table is a string. What do I call this table? This table is what we have in our schema.graphql. It's called transfer volume in upper camel case. It is a string, so we'll put strings around it. Transfers, transfer singular, transfer volume, and the key is going to be the address, right? Because that's a unique identifier. Transfers dot address. So there's our row, and on this row we have we can click on the row, and we have these following properties. So we're going to use set. So we're basically, what we're doing here is the row or the table is our entity, and then we need to fill out these fields, which is going to be the dot set. So we're going to go dot set name, symbol, address, volume, right? So here we're in the loop. So we've created a row, and on this row, we're going to use dot set. So here we have our name and our value. So these have to be identical to your schema, right? So same order, same capitalization. So our name and the value is going to be transfers dot name, right? And we are going to set another one, which is what is symbol, and this is going to be transfers dot symbol, and address, transfers dot address. And for the last one, uh, we need to actually use our get at method, right? So still within the loop, at the top of the loop, we need to get this value out of the store. So, we're going to use an if let. So if there is some value, right, because there might not be one, um, if let some value equals, now we'll use our store that we imported, and we'll use our get at method. And the ordinal, we already talked about that. That's going to be 0 because we're not using it. And the key is the transfers address. Transfers dot address. Because we're looking at the store, we're looking at the specific key. We're like, okay, how many times did our value of 1, how many times did our counter tick up per transfer that this NFT went through? So here we're storing um, this value inside of value promptly named, and we need to access this value all over our table. So we're gonna basically put this. I did this in the wrong order. But we're gonna put our whole tables thing inside of uh, this so that we have access um, to our value here. So when we go to dot set this field here, our volume, right? The whole point of this substreams is to get the count, right? The value, which we got out of here. So iterate over the transfers, that's done. Get the volume from the store, did that, and then create entity changes, right? That was this last step right here. Okay, that looks good. And let's continue forward. So we want to test our graph out. So in the make file, this time we're going to run make GUI instead of make run, which is just a little nicer to use. So let's go to our make file, and this time we want to test graph out, right? Because that's the one we just made. And let's go over 100 blocks, and let's run make GUI to do that. Okay, so we have an issue here. It's probably a typo somewhere. What did it say? So on line 46, it doesn't like store add. Line 46, huh? Oh, this is a mistake made way earlier. Transfer. All right, looks like it will not, actually. That did not fix anything. All right, so the issue is that I had misspelled. It's store transfer volume, not store transfers volume. So, yeah, the plural and non-plural stuff can definitely get tricky. I believe this is singular too. So let's go ahead and make GUI again. Okay, great. So, this works. Now, let's see how we can check to make sure our output's correct. So we can use the tab to navigate uh, to the output tab, and we can use U and I to switch between modules and O and P to scroll through blocks. So right here I'm pressing tab, and I can switch between these. So we want to check the output, and here we're looking at the output of graph out, but we can use U and I to also look at different ones. So we want to look at a graph out, and we want to look specifically at block number 15,082,000. So we can use O and P to scroll through the blocks. So we'll scroll all the way to 82, which we perfectly have. And let's validate our output. So create base C 192. So look for 192 here. And let's check it out. Boom, 192, right? Base C. Cool. So everything is correct. And in the next section, we can use Apollo Client to basically query our subgraph. But this is beyond just making a substreams. Your final step here is to make pack. And this will give you an S package that you can use however you like. Currently, what my friend Ben and I are working on is like a Java. It uses a Substreams JS library where you can drop your S package in there and basically turn it into JSON and then do whatever you want with this data. So the next step here is to run make pack, and this will generate an S package which will appear somewhere over here. Boom. There we go. We got a bunch of binary or some kind of non-human readable stuff. So that is the end of building this substreams. That was it, right? You can go through the rest of this challenge and hook it up to your front end. It's pretty cool. you can see you can actually visually, you can visually see the data in make GUI, but you can actually see it pop up on your front end or in a subgraph. We go through how you can make a subgraph, but this is the entire substream start to finish. So some of these get pretty complicated with, like, a bunch of map modules, a bunch of stores, doing a bunch of events. This is just very simple to get you guys accustomed to uh, looking at the libraries and seeing what the available options are for you to filter your data, to aggregate your data. You can build some really, really cool things with substreams, and so that's why I wanted to show them off. And I hadn't seen a video of a substreams, start to finish yet, so that's why I also wanted to make this. Um, so, just to give another whole overview, is we are taking in blocks into our map module, and we're just filtering it so we're getting only the transfer events, and we're only getting transfer events that involve the word ape, and we're putting these into a protobuf, which we defined in our contract.proto. And then we're collecting all of these uh, protobufs, all these transfer protobuf into transfers, and we're passing transfers into our store module. And our store module iterates over all of these transfers, and anytime it encounters um, the same address, it'll basically just add one in the key value pair, right? Because store modules are key value pairs. So we need to use the store add int64 method to do that. And then we're done. Now we have our store module. And finally, in graph out, we are getting our store modules, or our store module, just so that we can get the value on this line. We're using store get at. And we need our transfers, right? Our transfers protobuf to actually be able to iterate over all of them. And for each transfers, we're basically just populating this table, and then this table is becoming an entity, and we can put it into our subgraph. So after you're done with all that, run make pack, and you're done. Now you have your S package, and you can choose to put that, um, you know, you can put all this data into a subgraph or a database. All right. If you guys found this video useful, like and subscribe, and I'll be making more programming related content soon. Thank you for watching.